science plays a vital role for economic development and societal well-being. Understanding this, the Academy of Sciences Malaysia was established with a mission to be Malaysia's thought leader in all areas of science, technology, and innovation. To realize its mission, ASM harnesses the nation's top scientific minds to chart the STI direction and facilitates the implementation of an innovation-led economy for the country. ASM's commitment lies firmly in fostering a culture of excellence in STI in Malaysia. ASM does this by providing independent, credible, relevant and timely STI input of national and international importance to the country. Our network of expertise comprises Malaysian scientists, engineers, and technologists who specialize in various disciplines. The Academy assists in upgrading the nation's technological capabilities in the industrial sectors by producing high-quality publications such as peer-reviewed journals, monographs, and books. In addition, ASM also provides input on current and future technology trends to be considered and taken up by the government in driving the nation's economy forward. To provide Malaysian scientists with the best opportunities and exposure, ASM actively extends its international networks and collaborations. It currently has a range of multilateral engagements with renowned scientific institutions worldwide. The Academy also champions the need to grow the right talent in STI by cultivating interests in science, technology, engineering, and mathematics to the younger generation. In short, the Academy's ethos is proudly defined as Think Science, Celebrate Technology, Inspire Innovation. science plays a vital role for economic development and societal well-being. Understanding this, the Academy of Sciences Malaysia was established with a mission to be Malaysia's thought leader in all areas of science, technology, and innovation. To realize its mission, ASM harnesses the nation's top scientific minds to chart the STI direction and facilitates the implementation of an innovation-led economy for the country. ASM's commitment lies firmly in fostering a culture of excellence in STI in Malaysia. ASM does this by providing independent, credible, relevant, and timely STI input of national and international importance to the country. Our network of expertise comprises Malaysian scientists, engineers, and technologists who specialize in various disciplines. The Academy assists in upgrading the nation's technological capabilities in the industrial sectors by producing high-quality publications such as peer-reviewed journals, monographs, and books. In addition, ASM also provides input on current and future technology trends to be considered and taken up by the government in driving the nation's economy forward. To provide Malaysian scientists with the best opportunities and exposure, ASM actively extends its international networks and collaborations. It currently has a range of multilateral engagements with renowned scientific institutions worldwide. The Academy also champions the need to grow the right talent in STI by cultivating interests in science, technology, engineering, and mathematics to the younger generation. In short, the Academy's ethos is proudly defined as Think Science, Celebrate Technology, Inspire Innovation.
Distinguished guests, ladies and gentlemen, good evening from Kuala Lumpur and welcome to the Climate Change in the Tropics panel as part of the International Conferences on Tropical Sciences 2021. Joining me today for this very special session, we have 5 very eminent and authoritative speakers in their field. And in no particular order, we have Professor Joy Jacqueline Pereira. Welcome, Professor Joy. We have Professor Mark Howden. Welcome, Professor Mark. We have Professor Richard Corlett. Welcome, Professor Corlett. Professor Rita Colwell, welcome, Prof. And we also have Dr. Renzo Guinto. Welcome, Dr. Renzo. Before we begin, allow me to just put a bit of context to the panel session we have today. Although technically when we speak about the tropics, we often talk about the tropics as a geographical zone. However, when we usually think about the tropics, it evokes the tropical climate. It evokes a hot, sunny, maybe a wet climate. And although there is variability depending on elevation, depending on location, and so on, generally speaking, there is a large degree of commonality between the climate in the tropical zone. However, arguably, when we talk about climate change, there is rarely a focus on the tropics itself. Often, at the international level, climate change has become a political issue, which is a debate between developing country and industrialized nations. Sometimes it's a debate between fossil fuel producing countries and those that are not fossil fuel producing countries, those who have the resources and those who do not, and so on. However, from a scientific perspective, there's a lot of commonalities across the tropical zone where I think we will touch on a bit today. As the existential crisis that climate change has brought upon us, I think it's very timely we discuss this very important topic from diverse perspectives. As well, it is a very timely topic, as I think all of us know, world leaders are now gathering in Glasgow for COP26 of the UNFCCC Climate Summit. So, the question we would like to explore today is, what are the perspectives that we want to look on from a tropical perspective on climate change? For example, when we speak about mitigation, and now there's an ambition of achieving net zero emissions, what are the role, for example, of tropical forests to be carbon sinks, and so on. But perhaps more importantly, when we talk about climate change adaptation, what is the impact of climate change in the tropical zone? For example, we know for the past century, we've experienced a warming of about 0.7 to 0.8 degrees. And as a mega biodiverse region, how will these changes impact our socioeconomy and livelihoods? To discuss these complex questions, we will have to discuss it from various perspectives, and luckily for us, we have with us a list of diverse speakers that can touch upon these cross-cutting issues. Before I call upon the first speaker, allow me to briefly explain how the session will be conducted. Each speaker will be given 10 minutes to provide their opening presentation, and then we will move to the Q&A segment. Please do submit your questions on the Slido, and we will try to go through as much as possible within the time we have. We aim to conclude the session by 7:30 p.m. Malaysia time, or about in 1 hour and a half. With that, I would like to call upon our first speaker, Professor Dr. Joy Jacqueline Pereira. She is a Principal Research Fellow at University Kebangsaan Malaysia's Southeast Asia Disaster Prevention Research Initiative, or SIAPRI-UKM, and is also the Vice Chair of the Intergovernmental Panel on Climate Change, IPCC Working Group 2 on Impacts, Adaptation, and Vulnerability. So, Professor Joy, maybe you can set the scene, especially with highlighting what are some of the findings from the IPCC from a tropical perspective, and what does this 1.5 degrees warming mean in the context of the tropics? Professor Joy, you have the floor.
So, is the platform mine?
Please, Professor Joy, you have the floor.
If you can come. Yes, thank you. Thank you so much. And if I may ask the organizers to allow me to control the slides. Can you hear me well, Mr. Moderator?
Loud and clear, Professor Joy.
Thank you. Thank you. Thank you for the gracious introductions. Good morning, good afternoon, good evening to all my colleagues from the Tropics. I thank the organizers for the opportunity to share key findings from the IPCC 2018 report on global warming of 1.5 degrees. And I'll just highlight some aspects in the tropics. If Andy could let me share the screen again, because it was undone just now, that would be very helpful. But in going back to my talk, I would say that this is very timely indeed, since we are moving into COP26. So it's just like a refresher that allows us to go through the findings again, and give some thought to the decisions that we will be making in COP. So as you know, the IPCC is, if you could go to the next slide, the IPCC was established in 1988 by UNEP and the WMO, which is the World Meteorology Organization. My slide is not moving, so Andy, you will have to, I think, come in and. So please bear with us while we go through these technical aspects. Yeah. Andy, could you go to the next slide, Andy? Yeah. Perhaps you can take control and go to the, okay. So essentially, I was going to introduce the IPCC's history and the record, and if we could actually go to the next slide, that would be really helpful. Yes, and how we have actually, since establishment, we have made an impact where the first assessment report led to the establishment of the UNFCCC, and negotiations for COP26 will be taking place there shortly. And in the last cycle, our report provided inputs for the Paris Agreement. And next slide, please. And in the report, if we could go to the next slide. In the report, what we have reaffirmed that the atmosphere is changing, and we are because of human activities, and the change is already happening from the tropics through the poles, and all continents and oceans are impacted, and both rich and poor countries are affected. Can we go to the next slide? Thank you. Yeah, and this the atmosphere. Yeah, thank you. And the next slide. Yeah, I think we're taking time moving on. If you could open every slide, Andy, that would be helpful. So with respect to the report of the IPCC, we have been asking where we are now. And since pre-industrial times, we have warmed by about 1 degree, and the latest report gives us another 0.1 warming, and we are already seeing the consequences for people, nature, and livelihood. And at this rate, we will be reaching 1.5 degrees within the next decade, and depending on climate actions, how far we can delay it, right up to 2052. And the good news is that past emissions alone do not commit us on this pathway. There is a possibility to change the trajectory. Next slide, please. So in terms of the impacts of global warming, the IPCC did, in the report, all our scientists compared the potential impacts of global warming of at 1.5 degrees compared to 2 degrees Celsius. And the next slide will actually show you, if we could go to the next slide, that compared to 1.5 degrees Celsius, compared to at 1.5 degrees Celsius, compared to 2 degrees Celsius, we expect to have less extreme weather where people are living, including extreme heat and rainfall. Can I have the next slide, please? Yeah. And we expect to have, can you go back one? Yeah. And we expect to have, by 2100, the global mean sea level is expected to be 10 centimeters lower if we were to cap global warming at 1.5 degrees. And this will mean that we'll have about 10 million fewer people at risk. And of course, we expect a lower impact on biodiversity and species, in the smaller reductions in yield of maize and rice, half the amount of water shortages, and the lower risk of fisheries and livelihood, as well as 700 million people fewer that will be exposed to climate-related risks. So 0.5 degrees difference, several hundred million souls involved. And if you go into the tropics, you'll see that Southeast Asia and the Western Pacific, we are expected to experience the largest impact on economic growth. Can we go to the next slides, please? So the next slide actually shows you the level, how we expect the level of global warming to affect impacts. Next slide, please. Where you'll see these bars, and the dark colors in the bars, they denote areas where we expect change to happen. And in this context, we expect change in the tropics for warm water corals, for low latitude fisheries, coastal flooding. So depending on the strength of the bar, and you'll see that the horizontal gray scale here, that's where we are presently, and that's observation. Yeah. So depending on the departure from observation, the projection is for all these instant aspects to have been projected, and how the impact will translate, and many of these affect the tropics. Let me just take you to the next slide, just to show you the next slide, please.
You have 2 minutes left.
Yeah, and if we go to the next slide, you will see that we have red cell. We have impacts of heavy precipitation and food projection, number of hotspots, and you will see that the red cells actually indicate that is negative impact that we expect in tropical Asia. And if you could move on to the next slide, you can see that we have more orange cells, red, depending on how your color translate. For the tropics in Asia, you will see there is more. Next slide, please. You'll see more of the marine heat waves expected, and all of these are negative impacts, catch potential reduction, right up to challenges in fisheries governance. Next slide, please. And moving on, you will see even for the land-based aspects, there are some positives, but there are overall more negatives. Next slide, please. And these greenhouse gas pathways that we are taking, we can limit them, but it requires changes on an unprecedented scale, where we expect we need to have deep emission cuts in all sectors, a range of technologies and behavioral changes, and increased investment in low carbon option. Can we go to the next slide? Keep going, please. Yeah. I think I will finish way before your slides reach the end. Yeah. And in terms of, we need urgent and far-reaching actions, and we need carbon dioxide to fall by 45%, and everyone hit net zero by 2050. In fact, I would submit that you need to have net negative for some of the countries with historical emissions, rather than net zero. We should be, take care of those aspects. And
sorry, Prof. Joy, if you can.
Moving on to the last slide. So every bit of warming matters. Can we go to the last set? Where we have 0.5 degrees with 100 million people, and the more we delay, the more expensive it gets. So every year matters, and every choice that we make matters. Thank you, Aliza. I pass the platform back to you.
Thank you, Professor Joy, and apologies for the technical difficulties, but you certainly set the scene well. I think you've clearly highlighted the urgency of achieving even 1.5 degrees, but even worse if it's 2 degrees. And also you've highlighted there's a differentiated impact, and from a tropical perspective, it is mostly, of course, a negative impact, including on fisheries and so on. So I think you've highlighted some very key issues, and you set the scene well. And again, just highlighting the urgency of the climate crisis. Now, I would like to invite Professor Mark Howden, who will touch on more on agriculture and climate change. So I think this segues well from the first session, going a bit into detail on a sectoral perspective. Professor Mark Howden is a director of the Institute for Climate, Energy and Disaster Solutions at the Australian National University, and also is a vice chair of the IPCC report. He has tremendous experience on climate change, including on agriculture and food security, natural resource-based ecosystems and biodiversity, energy, water, and urban systems. So Professor Mark Howden, perhaps you can give your views, especially, again, from an agriculture and food production system in the tropics. Please, Professor Howden, you have the floor.
Thank you very much for the opportunity to speak here, and thanks to Joy for organising this for me to be here. Now, I'm just going to cover what's a really complex topic, and I'm going to deal with it very quickly, building off what Joy has already said. So next slide, please. So one of the really important points is that climate change is already affecting tropical agriculture right across the globe. This is a very recent study which took agricultural statistics and effectively took out the technology and management improvements that we've seen because of improved agronomy and systems, and looked at the residual climate change effects. And what this shows very clearly is that climate change is already impacting on agricultural productivity right across the tropics. So whether it's in Central and South America, or right through Africa, or through to Southeast Asia, the tropics are being most affected by climate change already. And globally, it's a very significant number. So roughly speaking, productivity would be 21% higher in the absence of climate change than we're observing today. So really important message first is that climate change is already impacting. We don't have to wait for 2030 or 2050 or 2070. It's here today. Next slide, please. So what are some of the components that are driving that? And Joy has already started to introduce these. So if we look at the top left-hand panel, this is temperature variation across the globe at a global temperature increase of 4 degrees. And you can see that different parts of the globe warm up at different rates than others. And so some parts of the tropics warm up faster than other parts of the tropics, and other parts of the world, like the Arctic and Antarctic, warm up much, much faster indeed. Next slide, please. So what does this mean in terms of critical things like heat stress? So heat stress affects animals, it affects crops, it affects humans, and through that affects things like labour productivity. And if we look at the top left-hand panel, we can see the historical frequency of heat stress days. So this is days where the combination of temperature and humidity is really problematic for activities outside. So for manual labour outside without active cooling. And we can see that across parts of the world, that's quite significant. Some places have 50 to 100 days a year, heat stress days in the past. But if we look at a high emission scenario towards the end of the century, down in the right panel, we can see right across the tropics of the world, almost every day becomes a heat stress day. So every day becomes a day which is challenging for humans to be out working in the farms, working in the fields, herding animals, and are difficult for the animals as well. So they will have reductions in productivity as well. Next slide, please. So the other part of the story is what happens to rainfall, because temperature and rainfall is so strongly influence tropical agricultural productivity. And we can see that patterns of rainfall change across the globe vary significantly. So in the central equatorial regions around the Pacific, increases in rainfall, but other parts of the tropics, significant decreases. And depending on where you are, those will have very significant different impacts in terms of agriculture productivity and what agriculture you may even be able to run in a given place. Now, importantly, what the IPCC studies show is that the variability in terms of rainfall associated with El Nino is likely to increase. So those wet years are likely to become wetter and the dry years are likely to become drier. And that will tend to increase productivity variability, or the variance of production, or the risk, if you want to think about it, because of this rainfall variability increase. We're also likely to see rainfall intensity increase. So as the atmosphere warms, it can hold exponentially more water. And that means when it rains, we get a lot more rainfall. We get bigger dumps of rain. And that rainfall can cause floods, and it can also cause erosion of our farmlands, which means loss of productivity. And at the same time, we're likely to see increases in potential evaporation as the world warms. So more evaporation can happen, which means our dams run out quicker because of evaporation from the water surface, and our crops and forage will grow less per litre of water because plants become less water efficient with high evaporation. And really importantly, these changes are happening faster and harder than projected just a few years ago. And that ties in with that story about climate change already impacting on agriculture that I showed in the first slide. Next slide. So there's been a whole range of different studies done on this, and this allows us to assess the risk, changing risk in tropical agriculture. So these are some of what we call the burning embers diagrams that Joy introduced in her talk, and particularly focusing on the two with the dashed ellipses around. That looks at tropical crop yield decline and food supply instabilities. And we can see as those colours change from white to yellow to orange to red to purple or sort of crimson, that indicates a change in risk. And we can see for tropical yield is that once we get to around 2 degrees, we're in the really danger zone. And for food supply instabilities, which particularly affect the tropics, as soon as we get to 2 degrees, we start to get into that purple zone. And that purple zone is where risks are assessed to be both unmanageable and likely irreversible. So we're likely to see very significant changes. Now, next slide, please. So there's been various studies of this, looking at crop yield under different crops for different regions. And next slide, and I'll just zoom into the one for rice here. And what this shows is future changes in crops assessed by different models, in this case rice, for different locations, India, China, Vietnam, Indonesia, and Bangladesh. And you can see consistently across the different models that there's likely to be significant reductions in productivity of rice with this sort of assessed at change in productivity per degree Celsius. And we can see that again, that corresponds with what we're already seeing, significant reductions in productivity. Next slide. So the really important things that we can do here are both adapt agriculture and to reduce our greenhouse gas emissions. Now, adaptation is simply changing what we do to adjust to the future climates that we expect. And adaptation is always highly contextual. It depends on the values. So the values of, say, an Indian farmer may be very different from the values of an Indonesian farmer in terms of what they want. And so the adaptation responses need to align with those values. Now, there's a huge diversity of possible options, and I list them here without going into details, but there's on-farm and off-farm adaptations. There's diversification options. You can have short-term tactical and longer-term strategic adaptations, an incremental change to existing systems, or transformational change to a different system. And you can have adaptation at institutional, regional, or value chain levels. Now, all of these adaptations require costs, and all of them change some knowledge that the farmers and the agri-industry has. But they're always done in anticipation of net benefits. And importantly, effective adaptation gives farmers a sense of control, and it reduces their stress and improves their strategic decision-making processes. But we don't want to overestimate the benefits from adaptation, because there are limits to adaptation, and we want to recognize that there's barriers to adaptation which we need to respond to. And importantly, we have to integrate adaptive responses with emission reduction responses. Next slide. And this emission reduction is really important because it deals with the core driver of climate change. That's greenhouse gas emissions. And agriculture and food produces around 29% of global emissions, about the same as electricity. So it's far too big to ignore. Now, there's many options for emission reductions in agriculture. So we can have improved on-farm management, looking at efficiencies and enhancing productivity. We can have direct reductions in greenhouse gas emissions by perhaps feeding animals, our livestock, with additives that reduce that methane emission, but can potentially increase productivity. We can increase soil carbon and biomass carbon so that we store more carbon in our systems, which enhances productivity in the long term. We can improve value chain efficiencies to reduce greenhouse gas emissions right across the value chain. We can reduce our post-harvest losses, reduce food waste, and even possibly change our diets in wealthy countries so that there's less meat and more grain. Healthier diets, which are often cheaper, healthier for the planet, healthier for people. And lastly, we can actually have land use change, such as introduce energy farming into our traditional farming systems. Next slide. And I'll just finish with that, but thank you again for the opportunity to talk here today.
Thank you, Professor Mark Howden, for also keeping exactly to time, but also highlighting that I think it was, just your slide on showing the heat stress in the context of the tropics really shows the alarming impacts that are bound to be faced by the tropics, or already faced, as you mentioned, in the tropics in terms of generally climate change, but also in terms of impacting yield, etc., for ensuring food security. But also you've highlighted something very important, is that there's no silver bullet. There's no single solution. There's always a diverse set of options based on context, based on values. And I think this is something that is worth perhaps bringing back again later or in another session, especially when we talk about the perspective of the tropics as well. So even within the tropics, there's a diversity of solutions, but also, of course, globally as well, there's this need to look into context. Okay, talking about the alarm, another crisis that is bound to face humanity is also the biodiversity crisis. I think some are calling it the Holocene extinction, some are calling it the sixth extinction. And, although the climate crisis has perhaps become the more mainstream issue now, but once again, I think there's also an impending biodiversity crisis that we are facing, and this is gaining also more and more traction. But in reality, it's not climate change or biodiversity, but it's also the interactions between biodiversity and climate change. To explore that further, can I call upon Professor Richard Collett, who has lived and worked continuously in the East Asian tropics, primarily focusing on ecology and conservation in tropical East Asia and the impacts of climate change. Perhaps you can elaborate further this link between climate change and specifically tropical biodiversity. Professor Collett, you have the floor.
Thank you very much for that introduction. I hope you can all hear me okay. As you can probably see from my pullover, I'm actually speaking from outside the tropics, but on behalf of the Shishmabanar Tropical Botanical Gardens, where I've worked for the last 9 years. Next slide, please. Understanding the impacts of climate change on tropical biodiversity is important basically for 2 reasons. First of all, most global biodiversity is in the tropics and may be impacted by climate change. Secondly, tropical vegetation has a major impact on global carbon storage and cycling, and this may also be vulnerable to climate change. Tropical forests have been a major carbon sink until recently, at least. Will this continue? Well, this depends on the impact of climate change. Next slide, please. Although understanding the impacts of climate change on biodiversity is very important, we actually know far more on climate change impacts outside the tropics. This is because there's been much less research in the tropics. I think the contrast with agriculture is striking, where there's been a fair amount of research. Also, there are very few long-term observations within the tropics, and you really need, particularly if you're looking at tropical forests, long-lived trees, long-lived animals, you need 30, 40 years of observations to see clear impacts of climate change. And we don't have that at many tropical localities. But also, tropical processes are not usually limited by temperature. So the responses to climate change are more complicated and less predictable than they are in the temperate zone. Where I'm sitting now in London, I can see the future of London basically by looking south towards Barcelona, perhaps, the future climate. But if you're sitting in KL, there's nowhere you can look for the future. The future will be novel, and this makes it very difficult to predict. Next slide, please. When we look at observed impacts, in the tropics, the clearest impacts have been on mountains, where glaciers have shrunk on the highest peaks, and both plants and animals have moved upslope over the last 40 to 100 years. And on coral reefs, where mass bleaching episodes that started in the 1970s coincide with sea surface temperature extremes and have got worse year by year. Next slide. So this is just a non-biological example, but it shows the dramatic effects of climate change in the tropics. This is Puncak Jaya in Indonesia, and shows the shrinking ice cap from 1936 to 1972 to 2015 to 2006. 2006, 2015. It's now almost gone. Next slide, please. And again, taking the Southeast Asian example on Mount Kinabalu in Sabah, moth distributions have moved about 120 meters uphill on average in 42 years after 0.7 degrees of warming. So this is an example of a long-term data set, 40 years observations, but we have very few of these. Next slide. There's also evidence from sites across the tropics, particularly in Africa and the near tropics, for shifts in the composition of plant communities, particularly in forest communities. And these are usually described as consistent with the expected responses to observe climate change. So these don't necessarily prove that these are climate change responses, but they appear to be, and they're consistent with what we would expect. So these are in lowland and in montane forests. Next slide, please. Now, although we're short of observations in the tropics, we have a lot of modeling studies, particularly in the last 5 years or so. Modeling studies of impacts on biodiversity have been based on correlative species distribution models, and these predict massive changes in the abundance and distributions of tropical species over the next few decades, and often massive extinctions. However, these models make a number of simplifying assumptions, and a lot of these assumptions are probably not true. More realistic models are certainly possible, but we don't really have the data in most cases to parameterize these currently, unlike agricultural plants in some cases. Next slide, please. There have also been modeling studies looking at the impacts on carbon storage and on carbon cycling. And this is a study that came out a couple of weeks ago, used a simple physiological model predicting large reductions in carbon storage by the end of the century. So you can see across the tropics, it's green, that's -20 to -10. This is the reduction in kilograms carbon storage per square meter. So that's a lot on a hectare or kilometer stage. However, these are very simplified models, and the authors themselves suggest that more realistic models may show different results. But whether the results will be worse or better, we really don't know at present. So next slide, please. To summarize, our understanding of the impacts of climate change on tropical biodiversity are hampered both by lack of research and lack of long-term records, also by the complexities. Observed impacts are clearest on tropical mountains and on coral reefs, and there's also evidence for compositional changes in lowlands and in montane forests. Modeling studies predict massive impacts on biodiversity and carbon in the next few decades, but these can't be verified currently and are probably not reliable. Again, I must emphasize this doesn't mean that there won't be impacts. We expect them, as we've seen from agricultural studies. But currently, we just don't know the magnitude of these impacts. So thank you very much. I think I better finish there.
Thank you so much, Professor Richard Collett. I think what is clear from your presentation is we know that the impact on biodiversity and the role biodiversity plays to mitigate climate change as well is very important, but still we we don't know enough. Of course, in terms of modeling, it's very complex and it's very difficult, but I think, as you mentioned, the lack of research on the data perhaps to input into those models as well is not sufficient at this moment in time, and perhaps this is something that, again, this conference can really look upon as a recommendation to improve the sciences behind the link between biodiversity and climate change, because as I've highlighted and you've highlighted, Professor Collette, it is really an impending crisis, and it's scary to know that we don't know enough to carve out the pathways to address this challenge. Okay, from one crisis we move to another, the crisis that we are all facing now. Health has become at the center of public policy, at the center of news in recent times because of the COVID-19 pandemic. And also, of course, there's links between climate change and health as well. With that, we have the eminent and decorated Professor Rita Colwell, Distinguished University Professor at the University of Maryland at College Park and Johns Hopkins Bloomberg School of Public Health. Now, her research is focused on global infectious diseases, water, and health, and perhaps you can share your perspectives, Professor Colwell, on the link between climate change and health. Please, Professor Colwell, you have the floor.
Thank you for the very kind introduction and for allowing me to participate in this excellent panel. We have the next slide. What I'd like to do is focus on infectious disease, in particular water. Safe water is an issue that I've spent a good deal of time studying. And you can demonstrate, and I'll use the example of cholera, and you can see that clearly with 1.5 billion cases of diarrheal diseases, including cholera, there are almost 2 million deaths every year. Next slide. What is important, and go through the slides, next slide, please. It's an acute water-related disease, and in fact, we are in a second pandemic. We've had 2 pandemics underway, COVID-19, and I'll speak about that as well, because we can learn from cholera and to be able to predict COVID from what we have learned about cholera. Cholera has been underway. We are in the 7th pandemic currently, so that means we are suffering 2 pandemics simultaneously. Cholera occurs in 50 countries and affects millions of people. Next slide. What we have learned is that the disease itself, the bacterium that causes the disease is naturally occurring. We did studies in the Chesapeake Bay on the east coast of the United States, next slide, and we were able to show that the vector for cholera, in fact, is a copepod, part of the natural plankton, the zooplankton in the oceans, and in coastal waters and in freshwater areas. So, next slide. So that the disease itself, the model that we were able to perfect over the last 30 years is that there's a relationship between warming and sunlight in the spring of the year with algal blooms and phytoplankton, and then followed by the zooplankton blooms, and then the zooplankton carrying the bacteria. When the zooplankton bloom crashes, the bacteria are released into the water column, and the disease then is transmitted. Next slide, please. And so the criticism was that what we had learned about cholera in the Chesapeake Bay not necessarily could be that which occurs in the tropical regions. So our studies took us to Bangladesh, next slide please, which showed pretty clearly, next slide, that indeed, although person-to-person transmission, next slide, occurs, really, next slide, it's the environment that contains the bacteria as naturally occurring bacteria that can play a role in carbon fixation, in the carbon cycle, and in the nitrogen cycles. Interestingly, cholera bacteria have enzymes that break down chitin, which is the shell structure of crustaceans, including copepods, as well as crabs, etc. May I have the next slide, please? We went back to Bangladesh in the Bay of Bengal, because it occurred to us this relationship of plankton and chlorophyll-bearing organisms. When Landsat, the satellite, was launched in 1980, we took advantage of that, and 20 years ago, we published these data showing that we could measure cholera incidence by satellite sensors that were able to detect chlorophyll, sea surface height, and sea surface temperature. And the relationship was startlingly clear and close. May I have the next slide, please? We've improved our model significantly. May I have the next slide? We've moved our model significantly, and we use much more sophisticated satellites today. May I have the next slide, please? What we now are able to do is to use the more sophisticated satellites. In the lower left, the Landsat was the satellite we used with its sensors 20 years ago. And currently in the upper right, we're using satellites that monitor movement of populations, and we also include cell phone data. May I have the next slide, please? This has allowed us to be able to predict cholera in Haiti. In 2015, we did a retrospective analysis, and on the left is our predictive model. On the right is the actual cases. We're now having improved the model. May I have the next slide? That allows us to predict cholera in Yemen. As you may know, in 2017, 15, 16, and 17, the worst cholera epidemic we had seen globally occurred in Yemen. And retrospectively, we were able to show on the left the risk of cholera and from our model, and on the right, the actual cases. We now provide, next slide, please. We provide data for the UN, the UNICEF, and the British Aid Agency. Every month, we provide a 4-week predictive risk of cholera in Yemen, and we're now working in Ethiopia and other parts of Africa. Now, may I have the next slide? This is my critical point. We have studied in the North Atlantic several years ago the plankton collected 40 years ago and stored in Southampton and in the marine laboratory in England. So we have these samples of plankton collected 40 years ago, 39 years ago, 38, et cetera, to the present. May I have the next slide? We extracted the DNA from the zooplankton collected over this 40-year period, and we were able to show with the records of the sea surface temperature in the North Atlantic off the coast of the US and off the coast of Europe and England, this increase in the numbers of vibrios, may I have the next slide, please, that occurred, and we were able to correlate that, may I have the next slide, please, with the actual, let me go back one, sorry, I'm trying to keep up here. We were able to correlate the diseases caused by vibrios, including cholera and other vibrio diseases in Europe, with this increase in the numbers of the bacteria we were detecting over this 40-year period during the time that the sea surface temperature was warming ever so slightly but significantly, allowing then the infections to increase in number in Europe and off the coast of the North Atlantic. We have the next slide, please. We've been able to take the model that we have developed for cholera and apply it to COVID. May I have the next slide, please? We've been able to show that this was done, our first attempt in April, May of last year. On the left is the predictive map for risk of COVID, and on the right is the actual cases of COVID, county by county in the United States. May I have the next slide, please? We now have an ongoing risk map monthly, and this is the latest risk map for COVID for the United States. So we've been able to utilize what we have learned about cholera to be able to do the same predictive capacity for COVID. May I have the next slide? I will close by one simple explanation of how we can utilize scientific findings. Because we had learned about the relationship of cholera and copepods, which are fairly large. Copepods are about 250 micrometers. So in Bangladesh, where villagers, may I have the next slide, take water directly from the ponds in the rivers, we were able to show that by filtering the water by a simple sari cloth folded several times, we educated women over a 3-year period in some of the remote villages of Bangladesh that they could filter the plankton out of the water system. May I have the next slide, please? And by this simple technique of using a sari cloth, about a yard of it, folded several times, covering the calash as they collected the water, next slide, provided a clean water that removed the particulates, and may I have the next slide, which allowed us to demonstrate a 50% decrease in cholera. So my last slide, next slide, this is clearly to understand that safe water is going to be the major problem we face in the years now and in the next decade or two. And that this, then, the supply of safe water and protecting from waterborne diseases will be the major issues that we have to address. The last slide, I have outlined this in a book published just a year ago. And that's the end of the slides. And I thank you for this very quick, but I hope understandable presentation of what really we face with water problems due to global warming and diseases transmitted by water. Thank you.
Thank you, Professor Colwell. I think you clearly highlighted the link between water and global warming, especially in relation to cholera. But I think what was very interesting as well is the utilization of science for prediction. I think as we face multiple crises moving forward, the ability to predict will be very essential in ensuring the ability to prevent as well future crises. But hopefully, of course, science will inform policy and action for that to happen. Okay, last but certainly not least, we have Dr. Renzo Guinto, who is a medical doctor by training and is an associate professor of the practice of global public health and inaugural director of the Planetary and Global Health Program of St. Luke's Medical Center College of Medicine in the Philippines. Concurrently, he is also the chief planetary health scientist and co-founder of the newly established Sunway Center for Planetary Health in Malaysia. Dr. Renzo is a trailblazer, and his research is certainly innovative, and I believe today he'll be speaking about climate change and decolonization. I think this is a very interesting topic and also very relevant because, again, as world leaders gather in COP26, often the discussion is disagreements between the global north and global south. Of course, we all know countries in the tropics are mainly I think all from the global south, as well as mainly post-colonial countries as well. And how we address these issues must be seen from different perspectives and different narratives as well. So I think, Dr. Renzo Guinto, the floor is yours. Please do enlighten us on climate change and decolonization.
Thank you very much for this opportunity. And it's really a deep privilege to be speaking in this very prestigious panel with some of the leaders in climate science worldwide. And there's just so much to learn from the wealth of knowledge that we've just heard so far in the room. I'm not here to talk more about the climate science, especially in terms of how climate change is going to impact, the health and well-being, for instance, here in the tropics. As already mentioned, I'm a medical doctor and I look at the intersections between climate change and public health. But Professor Colwell already fantastically described to us the major impacts, especially as they relate to water. But now I think, and as an emerging climate and health scholar, practitioner, and leader, looking at the state of climate science and climate policy at large.
Sorry, Dr. Renzo. Dr. Renzo, can you hear me? Unfortunately, we can't hear you. Dr. Renzo, can you hear me?
About decolonization. Basically, we want to decolonize everything from humanitarian aid, how we respond to crisis, all the way to decolonizing the way we're educated, decolonizing our buildings. You might have seen these pictures of statues of racist slave owners from the past being destroyed, dismantled, even decolonizing our diets. And a while ago, we were talking about or hearing about the impacts of climate change on agriculture. Maybe this is the time to actually think about, how do we return to the old diets, which are, promoted and protected by the indigenous communities that are not just healthy for our human bodies, but also healthy for the planet because of the low carbon and ecological impact that they generate. Next slide, please. And I've been very involved in this discourse around decolonizing global health. COVID-19, for sure, has magnified all these colonial attitudes in global health, from top-down imposition of policies and prescriptions from the global north to the global south, all the way to the vaccine inequalities that we are seeing now. Rich countries are able to hoard vaccines, while the poorest of the world's countries still do not have access.
Sorry, we are having a bit of technical issue with the sound. Dr. Renzo, can you hear me?
Oops, what's happening? Yep. Can
Okay.
anyone confirm?
Yes, we can
the
hear you now.
situation?
We can hear you now.
Yes, but the slides have not moved since because it will be, okay, now I can see it. So it ate up around 20 seconds of my time. I hope you'll add those 20 seconds
Please, go ahead.
towards the end. So now our question is, how about decolonizing the climate crisis, our approach to climate change, the climate movement, climate science? I think this is very much in relation to the objective of this conference and of this specific panel. How do we amplify Global South involvement, for instance, in the generation of climate science and a more inclusive understanding of the climate crisis? Next slide, please. But we need first to define terms, and I will do this very briefly. Decolonization is a noun which pertains to the undoing of colonialism, when countries, old colonies, have already been liberated from their colonizers. That is what you call decolonization. It's a largely political and historical process. For instance, the Philippines has already been decolonized for nearly 70 years. From American occupation, and other countries in Asia are also in the same boat. But the coloniality or the colonialism is another term which pertains to the untangling of the knowledge production systems, which are primarily Eurocentric or Western oriented. You know, this critiques the perceived universality and also superiority of Western epistemology, Western culture, Western knowledge system. So I think when we talk about decolonizing something, in particular decolonizing health, decolonizing education, also decolonizing the climate, we are actually pertaining to this definition of decoloniality. We are challenging these, universalist approaches that are usually emanating from the global north or from Western traditions. And then another related term is post-colonialism, which is interested in understanding the cultural legacies of past colonialism and imperialism. What's happening now in the Philippines, what's happening now in post-British Malaysia or Singapore. And so that is post-colonialism, which is connected also, of course, to the first two terms. But we're more interested in the one in the middle. Next slide, please. So very brief, and these are the ways we've actually colonized the climate crisis, the issue of climate change. Of course, we've colonized the planet. We always only think of colonialism as one country overpowering or dominating over another. But we as a humanity, for sure, have colonized the planet, from from olden times, during colonial times, all the way to the present day. And so really, if we want to address climate change, if we want to decolonize the climate crisis, what we really need to decolonize. So we've colonized the future of our children, of the next generations, and we are not leaving behind a planet that can allow the younger generations to live, to survive, to thrive. And so that is intergenerational colonialism. The present, civilization has colonized, the future ones, including the ones who are yet to be born. So that is quite another area of where colonialism is very much palpable and present in this discourse around climate change. Next slide, please. Okay, so that is my next slide a while ago. Can you please move to the other slide? Thank you. So the third is we've also colonized the movement, and I will not go into the details. You can see the headlines. The movement, unfortunately, is still very Western, very Northern, very white even, and very male. I was moved by Professor Colwell's last slide about sexism in science, and I think that is really still part of this discussion around decolonizing, the movement, making sure that, not just, the messengers, but also the message is truly inclusive and representative of all the peoples of the world. We can imagine in COP26 that there will be a domination of Northern voices with some few voices from the South. And unfortunately, the approach has always been tokenistic. You have a person of color as a representative in the panel discussion. I think we need to challenge those colonial practices in the climate movement as well. Next slide. And we've colonized the science as well. We've colonized the science in terms of the composition of the scientists, for example, in the IPCC. I still have to do some systematic analysis or counting of IPCC members. But for example, in the health chapter alone, there were 17 researchers or scientists there, and only 4 actually came from outside Europe and North America. None of the 4 actually came from a low or middle income country. And so how can we make sure that the next generation of IPCC reports are truly inclusive? I know Professor Joy is part of the IPCC, maybe one of the few representatives of this part of the world. We need to do better in climate science. There's a list from Reuters of the top 1,000 climate scientists. Only 5 are African, all 5 of them are white men. So they're not Black Africans or Africans of color, but also none of them is a woman. So we really need to do better in terms of improving racial inclusivity and diversity in the conduct of climate science and these reports. Next slide. Okay. And we've also colonized the negotiations. Our moderator already insinuated on the COP26 being really dominated by the big countries. The tug of war between China and the U.S. Pointing fingers as to who should decarbonize first and who should decarbonize the biggest. And oftentimes the climate vulnerable populations, the poor countries are used as pawns in these kinds of negotiations. So this is, I guess, another form of neocolonialism that is happening inside the closed doors of the COPs. And we've been doing COPs for 26 years, 26 times we've negotiated, and still progress has been very limited in terms of addressing perhaps the most defining existential crisis of our time. Next slide.
Dr. Renzo, if you can begin to wrap up, please.
Yeah, but I also lost around 30 to 40 seconds because of the delay. So we've colonized the solutions also, and the solutions have been focused on the technological. There's a lot of greenwashing, finance solutions, etc., but without really discussing about the root causes of the climate crisis, our flawed economic system, our inequitable policies that generate both social inequality and environmental injustice. And so when we talk about decolonizing climate change, we also have to make sure that the solutions that we are putting forward are really addressing the needs, especially of the most vulnerable and the most affected. Next. And then, of course, we've colonized the victims. They're already victims of the climate crisis. They're already going to be bearing the brunt of the climate crisis in the next decades. But they're also the ones not being provided support and assistance in terms of transitioning to clean energy, enhancing their resilience to climate change. The emitters of greenhouse gases are not the same countries as the victims, who are based in the global South, Africa, Asia, and some parts of Latin America, and of course the Pacific as well. Next. I'm almost done. So when we talk about decolonizing the climate crisis, I just want to give a word of caution that we should go beyond the cosmetic. Having more representation, more persons of color in the IPCC or in the movement, they're important first steps, but we need to go deeper into the colonial dimensions of this problem that is rooted in the economy, that is rooted in the policies, that is manifested in the negotiations, and even in the climate science that we generate. Next. And of course, these are really manifestations of the asymmetries of power and privilege. This is a nice caricature showing to you how they're all linked. Racism and patriarchy and white supremacy, all of these afflicting the discourse around the climate crisis. Next. And this is another interesting slide showing to you how all of these isms or these different types of supremacy, white supremacy, male supremacy over other gender identities, human supremacy over nature, and that's what brought us the crisis of climate change. All of these are rooted in this colonial machinery that we have, not just in the past, but even in the present day. Next. And that's why, I am very, very excited about this new concept and this new paradigm of planetary health, because in planetary health, we really acknowledge the interconnections of all these issues, and we listen to diverse voices, including indigenous voices, alternative knowledge systems. Next slide. I'm almost there. And I think that planetary health has a very strong decolonizing power. It really challenges this egological approach that we have right now, that we humanity are at the top of the pyramid of nature. We can extract, we can mine, we can consume, pollute, emit. And instead, we are shifting towards a truly ecological approach, which is not colonial in arrangement, but truly harmonious and holistic and compassionate and democratic. Next slide. And I think this is my last slide, and I highlighted a while ago the colonialism over the future generations and their ability to thrive and survive. I think part of this is for us to become good ancestors. This is a fantastic new book that was published last year, and really to decolonize our relationship with the future and the future children of the world. We need to be good ancestors to make the decisions that will not just benefit ourselves, but also benefit the health and well-being of the generations that are yet to come. So yeah, I think that's my last slide, and thank you very much for this opportunity.
Thank you, Dr. Renzo. I think you really highlighted, of course, the need for looking at climate change in general from a critical theory. You brought in a critical academic study, and specifically on decolonization. And I think what impressed me was not looking at it only from a nation-state perspective, but decolonization from various perspectives, including intergenerational, gender, and so on. So I think the message is clear there. There's a need to move beyond tokenism. I think that's the key thing here, and really think about how to address the systemic nature of colonialization within climate change, and broadly other topics as well. Okay, we have about 20 minutes left for discussion. Now, first, I would like to touch on, I think a few speakers already mentioned what's happening in the next few days, which is COP26. Now, from a science perspective, what would you like to see or should happen in COP26? I know, Professor Joy, you've highlighted in one of your slides the impact of previous scientific reports in terms of agreements, etc. So what do you expect in COP26, and what would you like to see from a scientific perspective to be agreed in COP26? Maybe, Professor Joy, would you like to respond first?
Yeah, thank you, Alizan. This is a personal perspective and not the perspective of the IPCC. And in terms of the COP the previous track record, we are moving in a good direction, but really I would like to see beyond COP and its pledges. What we want to see is sound implementation. We need to move beyond the articulation and pledges into real implementation, and that would be something that would be nice to see from a COP. Thank you.
Thank you, Professor Joy. I open this to all the panelists, but perhaps Professor Howden, do you have views on, maybe specific to agriculture, for example, what can be agreed in COP26?
Look, I think a really critical thing is just for countries to step up in terms of their emission reduction ambition. So we're clearly not going fast enough or hard enough to keep temperatures down and avoiding those danger zones that Joy talked about in her presentation and I covered in mine. And that actually means, looking at 45 to 50% reduction by 2030 and continuing that momentum out in the future years. I think I'd like to also see a really strong focus on adaptation, so climate adaptation, so that everyone everywhere can have the opportunity to adapt to the changes that they're seeing and experiencing right around them, and so that our grandchildren can actually live in a world which is as joyous as the one that we grew up in.
Thank you, Professor Howden. Professor Collette, do you have any views? I know in terms of Paris Agreement, there's, I think in Article 5, there's a mention in terms of sustainable forest management and so on, but there seems to be a lack of movement on REDD+ and so on.
So, I mean, I think that's true. I mean, I would agree with Professor Hoyt, with Mark and Joy, basically, that the key issue here is people need to step up on their emission reduction plans. And I think everything else is secondary. For biodiversity, we've had the first half of COP15 in Kunming already, in the second half next year. And it's unfortunate that the biodiversity and climate are basically treated in separate meetings and generally by separate ministries in the countries that are involved. And there perhaps could be more integration. But the big issue at COP26 is emission reductions. We have to do those now.
Thank you. Thank you, Professor Collette. Professor Colwell, COP26, your views?
I think it would be really critical to understand the threat that we have with respect to access and availability of safe water. We have spent a great deal, rightfully, focusing on CO2 emissions and air quality and the problems of pollution. However, we don't seem to be paying much attention to the fact that the amount of water that is actually potable is limited, and it is becoming, in most countries, highly polluted. And in addition, our oceans are now becoming polluted with plastics and the remnants of what we have been producing excessively. So that we need to really, I would hope that would come out of COP26 would be an analysis of how much time we have left for availability of water for the populations that we're anticipating to reach about 10 billion. I think we're now at about 7 or 8 billion. And so there's non-computing capability that's occurring. And I would like very much to see some focus on water as a human necessity for life on this planet.
Thank you, Dr. Colwell. I think also, like Professor Collette also mentioned, there's the lack of integration across these different issues that is a bit concerning, while the focus is on reducing emissions, but there are other sectors as well that of course will be impacted heavily, and therefore this links with, I think, Professor Howden and Professor Joy as well, working on adaptation providing more focus to adaptation. Dr. Renzo, on this issue, what do you expect coming out of COP26, but also from your presentation, also a bit of comment on your views on the process itself? Has it been more equal? Did it give a bit more platform, do you feel, from Global South, Global North, from intergenerational and so on? Dr. Renzo?
Right. And of course, first and foremost, I'll echo what everyone has already mentioned. We want and we demand for deep emission cuts if we are to actually achieve the targets of the Paris Agreement. We only have 9 years remaining. It's been described as a decisive decade. And so the time is becoming slimmer and slimmer for action. What I hope, and this is not just for COP26, you know, after 2 weeks, the COP26 is finished, it's over, and then we are all looking forward to the next one, right? And to the next one. And I think what we need, and perhaps this is how, you know, my presentation is contributing to this, there has to be a real, you know, and you mentioned a while ago that the phrase critical analysis, right? A critical analysis of the political economy of this. And I'm sure we're not devoid of social scientists who are observing the negotiations, but perhaps we need to bring in more social science and more even you know, justice and equity and the colonial approaches to even inside the negotiations table. I don't know how can we do that, but I think we need to be a bit more, I guess, activists in our work, and not all scientists will agree with that statement. But I think in this day and age of the climate emergency, the time is running out. We don't have any choice but to really step up and to make sure that the science that we generate really makes a huge dent in policy making and decision making. I think there's also an opportunity, and I know for this upcoming COP, it might be too late. Remember, there was even an issue when, some organizations are concerned that a lot of the representatives from the Global South will not be able to attend COP26 because, one, they're not even vaccinated, and two, travel restrictions are still existing. But in the future ones, I think we need to do a better job in making sure that there is true inclusivity in terms of the voices who are speaking up about climate change, but also in climate science in general. I mean, we've done 6 reports already, and the 2 working groups are still yet to publish their reports in the coming year. But we will definitely have the 7th, the 8th, the 9th in the future, and we need to do a better job to make sure that our climate science is truly inclusive of all peoples of the world. Thank you.
Thank you, Dr. Renzo. On that note, I'll take questions from the audience, and there's a very relevant question there to what Dr. Renzo brought up. The question is, how do we overcome the discrepancies in engagement of developing countries and scientists from developing countries in the science negotiations, as brought up by Dr. Renzo? I think we've heard from Dr. Renzo. I would like to open this to perhaps Dr. Joy and Professor Joy and Professor Mark Howden, who's been a part of the IPCC specifically. Your views on this, Professor Joy?
Yeah, I certainly don't dispute that we need far more participation from researchers in the tropics, particularly within the IPCC. Yeah? I myself have taken great efforts in this cycle, having been a member of the Bureau, to actually conduct a lot of workshops. And I've done this with science institutions in the region. For example, we did with Professor Mazlan Uthman, the convener of this Trop Science, sessions to build up the capacity of young scientists in the Pacific and in Asia, and how they can actually review this report, in the hope that if we train them to review the reports, this will be the future cadre of people who can then come into the IPCC. So we've done so much of work on that. And even when we take in scientists into the IPCC, I have one observation, is that you have nominations coming from so many countries, from Europe, from North America, but you're so hard-pressed to get nominations from the tropics, from the developing world. Their governments themselves do not nominate their scientists. And this is where I think science institutions have to play a role, particularly the Academy of Sciences in the respective country, play an active role to actually nominate their scientists, even if their government focal points do not do so. Thank you.
Thank you, Professor Joy. Professor Howden, do you have your views on this issue?
Oh, look, I think Joy's introduced that well. I'd just like to make the point that what Joy said is that when we're selecting authors, we can only select from the pool of nominations. And there's a great deal of attention being paid to ensure balance in the author teams to the best extent that we can. And there's about 8 different dimensions of selection that are needed, but they include developing country representation, gender representation, disciplinary expertise, and various other things. And so I think it's very clear that the limiting factor is not the selection process itself. Once we actually get those nominations, the limitation is the nominations, and that's why, as Joy said, really important to build up the capacity in developing countries, particularly in relation to tropical countries, but also to ensure we get nominations well outside the physical sciences. So, covering things like history and anthropology and other disciplines.
Thank you, Professor Howden. I'll just take another question from the audience. The question is, how will warming in the tropical ocean affect the global climate and exacerbate problems of the tropics? I think, Professor Colwell, you covered this a bit, but would you like to expand a bit and elaborate on this question, Professor Colwell?
Yes, I do think that the question is an extremely important one. The effect of the oceans is quite dramatic. We are beginning to see the kinds of changes in the coral reefs, which are a prediction of what will happen in general. We're seeing loss of diversity. We're seeing acidification in the oceans, which is changing again the diversity in the fisheries populations. And many countries, populations of many countries depend on the fish as a protein source, a food source. And the problem with the ocean is it's so vast that it gives the sense of security and safety. And I think we're going to find some very dramatic surprises with when we finally understand that the circulation of the oceans, for example, the gyre of the North Atlantic and its effect on climate will be very dramatic, and these will not be easily solved problems. So it's a massive kind of change that seems to be subtly occurring now, but will have very dramatic and very obvious and dangerous effects in the decades ahead. So the oceans keep us alive, but if we don't keep the oceans alive, we aren't going to survive. It's that dramatic. So it's a very good question, and I appreciate it. And I'd like also to make a comment that I want to emphasize the role of the social behavioral sciences that we have not included in the natural sciences conquering of the earth and all of the resources of the earth. If we don't understand human behavior, we aren't going to really solve much, no matter what we decide at COP26 or the other COPs thereafter. So those are my comments, and a very good question from the audience.
Thank you, Professor Colwell. Professor Collette, would you like to also respond to this? I think you highlighted in terms of observations, coral reef, for example, are the biggest impacts. Professor Collette, you are muted. Professor Collette, you are muted. We cannot hear you. Apologies.
Professor Colwell's fortunately already covered anything I could say on this. So I don't think I should add anything more.
Okay, we're at the tail end of this panel session. With about 30 seconds each, can each panelist just have your closing remarks in highlighting, from a tropical perspective, what is the way forward? What is at least one thing that can be done, perhaps in terms of collaboration or so on, to address climate change from a tropical perspective? Perhaps I'll move in reverse order, starting with Dr. Renzo. And please, Dr. Renzo, your parting thoughts and way forward.
Yep. Well, again, thank you for this opportunity, and I'm just really thrilled to be in the company of amazing climate experts. And I think what gives me hope is that the next generation of climate experts and researchers and leaders, of which I'm a part of, will be building on the shoulder of these giants. And I think there's promise in a more decolonized climate science. As already mentioned by Professor Joy, we try to build more capacity in the global south, especially here in the tropics. So I'm just really excited, despite the, I might have painted a very bleak picture, although climate change is indeed quite a serious challenge that we need to confront. But I think there's hope and optimism as we see all these new developments. And it's not just with the IPCC. I think in climate climate science and climate engagement in general in the next couple of years and decades, I'm pretty sure we will do a better job in making it more inclusive and more accessible to all. Thank you very much.
Thank you, Dr. Renzo. Professor Colwell?
I'd like to speak on behalf of the young generation, which is going to have to live with climate change. And fortunately, they're beginning to speak out, and I hope that they will forge a movement and action, because it will be those young people who are living with climate change and who can make change now and not wait for the government.
Thank you, Professor Colwell. Colette?
From a biodiversity viewpoint, the thing we need for the tropics is standardized long-term monitoring. We need to see what's happening. The models are important, but we can't parameterize them if we don't have long-term observational data.
Thank you. Professor Howden?
Thank you. I'd like to see, as Professor Colwell has said, that active involvement from young people, particularly on climate change. This is the world they're going to inherit, and they need to be, satisfied that they've done what they can to actually make it a good world. But I also, referring to Professor Colwell, I think there is a real need for inspiring narratives around science, science which goes from the basic understanding of processes through to those outcomes where you're improving the lives of those women in India, for example, and using simple understanding of the processes can lead to really significant benefits to people and to environments. And so I think those sort of stories are really great to enthuse the next generation of people to take up the cause, to take up science as a means of finding solutions, and being part of a broader movement which is integrative with social and political issues as well.
Thank you, Professor Howden. Professor Joy, you have the last word.
Yeah, thank you. I think my wish list would be a consistent and deep engagement between the science institutions in the tropics with an explicit programmatic focus on young scientists, because I have seen in the Western Pacific, in the Pacific Islands, how innovative they are. And that's the kind of innovation that we need to mainstream in the region. Thank you.
Thank you, Professor Joy. We've reached the end of our panel session, and I think I won't summarize, I won't give a long summary because we are running out of time, but really just to highlight that what really captured me was the importance of narratives here, whether it be a scientific narratives, whether it be economic narratives, whether it be a political economy narrative. It's very important to, as Professor Colwell said, bring this human behavior as part of the issue on climate change. Without that, I think we'll be using old narratives that some may work, but some may not. And again, this climate crisis is very urgent, and therefore we need to create this movement as highlighted as by many of the speakers today. Now with that, I would like to just thank all the very eminent, very capable speakers we have today for your contributions to this panel session. I would like to thank the organizers as well for organizing this panel session and the conference as a whole. And I would like to thank all of you audience out there for giving your questions and following this panel session. With that, I close the session on climate change and the tropics. Thank you very much.
Thank you, fellow panel members and moderator.
Thank you.
Bye-bye.
Enjoyed all your presentation. Marvelous.